Welcome to topic 3, sampling distributions for proportions and sample means. So, as we did in the Gettysburg Address activity, here, sampling distribution shows the sample proportions or the sample means for many different random samples. If you remember from last class, you all took averages of the word lengths of randomly selected words, and you put on the board X with a bar over it to represent a sample mean. And then what we saw is as the sample size increased, the variability in the sampling distribution decreased. And the reason for that is as your sample size gets larger, you know more about the population, so your estimates are going to be more accurate. So sample size goes up, variability goes down. So in this first example here, what they're asking you to do is match each of these simulated sampling distributions with the correct sample size, 20, 60, or 120. So really what you want to focus on investigating is which has the most variability and the least variability. So here, this is the most spread out distribution. This is the least spread out distribution. Yes, you have this unusual point here. So you're going to be able to say that this one is going to have a sample size equal to 120 because smallest variation. This middle one is going to have that medium sample size equals 60. And this one at the bottom is going to have the largest sample size. The small sample size of 20 because this has the largest variation in the sampling distribution. This is a lot more spread out than the other two graphs. So if we take a look at page 2 now. Let me escape. There we go. Okay, why don't you take a minute and try this example here. When you feel like you got a hang of it, come back to the video after you pause it, and I will go over that. Okay, so on the top of page 2, you're looking at the top distribution having the largest amount of variability. So the sample size is going to be the smallest. The bottom distribution has the least amount of variability, so it's going to have the largest sample size. So this is going to have a sample size of 600. This one here that goes from 0.6 to 0.79 is going to have the middle sized sample at 300. And this one that has the most variability is going to have the small sample size at 100. So going on to the bottom of page 2, really getting into these ideas of margin of error and confidence intervals. When we take a sample, we're not certain of the results. So we have something called a margin of error. Typically, you see this a lot with when it's time for like voting. You might see something like the polls say candidate A has 47% of the vote, plus or minus 4%. That plus or minus is the margin of error. So it could be as high as 51 or it could be as low as 43. So that's the margin of error. And there's ways you can increase or decrease that if you go on to take AP stats. But a confidence interval gives us a reasonable range of values for whatever we're measuring. So for example, if we wanted to measure what's the likelihood of, or how much snow are we going to get tomorrow? I put in here a Garfield example just as a reminder for myself. So if you turn on the forecast and they say there's 100% chance tomorrow that we're going to get between 0 and 1,000 inches of snow. Okay, yes, that's true, but it's completely worthless because you don't know if it's going to be 90 degrees outside or if it's going to be like the Arctic blast of the century. So what we do is we typically use a high confidence level. What we're going to see in this class is going to be 95% confidence. And then we're going to use that confidence interval to say, is what happened in the sample, is that reasonable or not reasonable? Is it likely, unlikely, usual, unusual? And that leads into this concept of statistically significant. And this is going to be an incredibly important concept that we use here. So for statistically significant, that means our results are too unlikely to have occurred by chance. So that means if we don't think that they occurred by chance, then they occurred due to there actually being a difference. And there's two ways we can check for statistically significant. We can find our confidence interval, CI, confidence interval, and see, is our value in the confidence interval? If it is, that's likely, and it's not going to be statistically significant. If the value is not in the confidence interval, that means it's not a reasonable value, so it's unlikely, and it is statistically significant. That's one way we can test for statistically significant. The other way is to do what's called the 5% rule. Basically, if something happens less than 5% of the time, we say it's unlikely. And if something occurs more than 5% of the time, that it's likely. Unlikely corresponds with it being statistically significant. And if it happens more than 5% of the time, we say that that's likely and that's not statistically significant. So in order to calculate the margin of error, what we're going to do is we're going to take 2 times the standard deviation. So your margin of error is literally just 2 times the standard deviation, which they will give you. And to calculate a confidence interval, you take the mean plus or minus 2 times the standard deviation, which will be given to you. So if we take a look here on the next page, we'll do a couple of examples. Oops, let me delete that. And there we go. Okay, so in question 1 on page 3, we're taking a look at this. Let me see if I can zoom in a bit. Yeah, here we go. They want the interval that reflects the 95% critical reading scores. So what they've given us, let me try to make this a little bit smaller, is they gave us the mean and standard deviation. The mean and the standard deviation were 496 and 115 respectively. So we know that to calculate a confidence interval, it's the mean plus or minus, I don't have a plus or minus symbol, 2 times the standard deviation. And if we do that, 496 plus or minus 2 times 115 is 230. And that's the format that these answers are in. So they're just showing you the margin of error. So it's the mean plus or minus the margin of error. So that would be the solution for number 1. If we go on to number 3, I mean. So now we're looking at an insurance company in Rochester, New York, and they're looking at the proportion of drivers who are male. So they want us to determine the margin of error to the nearest thousandth here. We have the mean and standard deviation given to us. So we're just going to utilize those values to calculate this. So it's going to be the mean, 0.531, plus or minus 2 times that standard deviation. And when we calculate that, you're going to have to do it one step at a time in the calculator. The 0.531 minus 2 times the standard deviation is going to give you this lower bound of, in this case, let me check the answer key. What is that? Oh, we're not even calculating the confidence interval. I'm sorry. The margin of error is just going to be this. And then when we do that, it's 0.99. Let me double check the answer key on that. Yep, because they wanted nearest thousandth. So that was just the margin of error, is just what you're adding and subtracting, or 2 times the standard deviation. Then in part B, they want us to come up with this idea of this plausible interval containing the middle of 95%. So that's saying actually do the confidence interval. That's what you noticed I started to do there. So it's going to be the mean plus or minus that standard the margin of error, I should say, which we calculated above, and that turns out to be 432,630, 0.432 to 0.630. Again, they want it to the nearest thousandth, so we're just going to utilize our answer from part A for the margin of error. So I'd like you to do questions number 2, 4, and 5. So 2, 4, 5. Pause the video now and then come back and I'll go over them. So in question 2, you're looking for the 95% confidence interval here. So you're just going to be taking the mean, which they told you was 25.5, plus or minus 2 times the standard deviation. When you do that, you're going to get 25.5 plus or minus 3, So if you subtract 3 and add 3, that's where you're going to get those 22.5 and 28.5 from. Question 4, very similar, 95% confidence interval. So again, you're going to take the mean plus or minus 2 times the standard deviation, which they've given you, and that's going to lead you to 0.12 to 0.36. And then the last one, number 5, they want the 95% confidence interval. They give you the mean and the standard deviation. You're going to notice a lot of repetitiveness in this lesson. So 310 was the mean, plus or minus 2 times the standard deviation. You end up with a confidence interval of 238 to 382 milligrams. So that's just a quick intro on confidence intervals and margin of error. Next, we're going to start talking about your sample data, and is it a usual, unusual, statistically significant, not statistically significant.